Welcome to Prince Maths Clinic, the e-learning solution at your pace and time.
Good day and welcome once again to class. Today we shall be considering these questions involving calculus, and the aspect of calculus we shall be focusing on is integration. We should know that integration is the reverse process of differentiation. And when we say differentiation, we mean simply finding the change in y to the change in x. And when we reverse that process, we reverse the process with the process called integration to give us back our original what value that was differentiated. What do I mean? If we are given y to be equals to x to the power of 2, if we are to differentiate this, it means we are to say change in y over change in x. And to differentiate simply means what? Take this 2 that is in the power, multiply this x squared, so this becomes 2x squared, then remove 1 from the power. And simplifying this, you will have 2x. 2 minus 1 is 1. This gives us what? 2x. Now, this value has been what? Differentiated to give us this value, which is 2x. At peradventure, we want to integrate this value to give us back x squared. What do? Remember that when we differentiated, we got this as what? 2x. Now, I want to integrate. What do? I will use this dx, multiply this, so this becomes, or multiply both sides by dx. So dx will cancel dx, so I'm left with dy. Then this becomes 2x dx. So if I integrate both sides, when I integrate dy, I'm going to get y. Then what are we going to do to this particular value? We don't integrate a constant. 2 is a constant. I'm going to bring it out. Then I'm left with x dx. So in integration, this is what we do. Remember, when we differentiated, we what? We use this 2 to multiply this and subtracted 1. But in integration, we simply do the reverse. And what is the reverse? Instead of subtracting 1, we add 1 and divide instead of multiply. So this becomes what? If you integrate this, you are going to say 2 into x. The power here is originally 1. Then we are going to add 1 to it instead of subtracting. Then what is the sum of the powers? 2. So we are going to add 1 plus 1 gives us what? 2. Then simplifying this becomes 2x to the power of 2, all divided by 2. Now, 2 we cancel 2. We are left with x squared. So our y is what? X squared. Then we are going to add a constant to it because we don't know. Let's pretend that we don't know that it's just x squared. So there could be a constant or a value added to x squared. That is why we add this constant. So I'm going to be using this principle that we have just exercised in what? This to solve this set of questions. In doing this value here, write out a question. This is 4 divided by 3x plus 4 all to the power of 4, then dx. Now I am going to use the method which we call substitution method. And why did I say substitution method? There is a value here that is a function, right? So this function is carrying a power of what? 4. So I am going to say let 3x plus 4 be equal to u. For instance, you can put any letter you like, but I choose to use u. So I want to differentiate u with respect to the variable here x. So if I say du over dx, if I differentiate 3x, I am going to get 3. And if I differentiate a constant, I'm going to get 0, because the power of x in a constant is 0. So just say 0 times 4, which is 0, then x, 0 minus 1, right? Now, irrespective of whatever this power is, as long as it's multiplying 0, it becomes 0. That is why when you differentiate a constant, you get 0. So remember, we want to substitute. I want to find what dx will look like here. So therefore, if I make dx the subject of the formula, my dx here will now be what? Du over 3. So I'm going to substitute everything I have here back into this. Therefore, my integral, which is 4 over 3x plus 4 to the power of 4 dx, will now become the integral of 4 over, now instead of everything I have here, I'm going to put u, then carrying a power of what? 4. Then dx, instead of dx, I'm going to put du over 3. Now, what do you observe? We have a constant here, right? Good. So this constant is actually 4 over 3. So I'm going to pull it out, the integral again. Then I'm left with nothing there, so I'll put 1 over u to the power of 4. Then du. It should come out like this. The variable here is u, so you should have du there, right? Then this can be further simplified, because 4 over 3, when you have 1 over any number, for instance, 1 over x can be written as x bar 1, right? X over 1 over x can be written as x bar 2. So when you have 1 over e to the power of 4, it can be written as what? U to the power of negative 4, then du. Now, this is what I am going to integrate. Integrating this, remember the rule, add 1 to the power, then the powers here, add them up together. Minus 3 plus 1 gives you minus 3. Then add your constant. As long as you have integrated, always add your constant. Let's simplify this. This becomes 4 over 3 u to the power of negative 3, everything over negative 3. Mind you, there's a negative here. So this plus c. So let's further simplify this. If you simplify this, this is saying 4 over 3 divided by, right? Divided by 3 over 1, or negative 3 over 1. So this becomes 4 over 3 times negative 1 over 3. This will become negative 4 over 9. So I'm going to put a negative 4 over 9. Then this can be written, remember, we said that when you have 1 over u, it can be written as u to the power of negative 1. So this is negative 3. So this can be 1 over u cubed. So this becomes what? Times 1 over u to the power of 3. Then plus our constant. So 4 times 1 gives us 4. So I'm going to take out this 1. So that means that our value becomes minus 4 over 9. Then what's the value for u? We said let u be 3x plus 4. So we put it here, 3x plus 4. You put it back. Then it's carrying a power of 3. then plus constant c. That is the value that we arrive at after integrating this particular question. Let's look at the second question. We're told in the second question that the integral of x to the power of 3 e to the power of x to the power of 4 plus 4 dx. We want to integrate this. So now let's look at the part that is a function. The function here is x to the power of 4 plus 4. So using our u substitution again, we are going to say let u be equal to x to the power of 4 plus 4. Or you can say let m represent this. Therefore, I can differentiate this u with respect to x. So if I differentiate the u with respect to x, 4 times x, then you say 4 minus 1, and 4 minus 1 will give you 3. Then if you differentiate a constant, you get 0. So this implies that if we want to get our dx now, our dx will just be what? Du over 4x to the power of 3. That is what our dx will be. So now we can substitute back into the question. Hence, the integral of x to the power of 3 times e to the power of x to the power of 4 plus 4 dx will now become x cubed, then multiplied by e. Everything here has been called u. Then we have what? Dx now has become du over 4x cubed. It's getting interesting, right? Good. So now you look out for the constant. The constant we have here is 4, which is 1 over 4. So pull that out. Then you have x cubed multiplied by e to the power of u multiplied by what? Du over. Remember, we have pulled out 1 over 4. So we have what left here? X cubed. So x cubed here cancels out x cubed. Remember, we have not integrated, right? All we are just doing is to simplify. So this simplifies to become 1 over 4 integral of e to the power of u du. So at this stage, we want to integrate. So you put 1 over 4 to integrate. We know that there are some standard integral value. And the standard integral value said if you integrate e to the power of x, the result will be e to the power of x. So our x here is likely to be u. So if you integrate e to the power of u, you are still going to get e to the power of u. So integrating this, therefore, you have e to the power of u, then plus our constant c. Then at this point, you have to recall that you have called u to be x raised to the power 4 plus 4. So therefore, everything becomes 1 over 4 e to the power of what? X to the power of 4 plus 4, then plus our constant c. This is now the result we are looking for. And with this, we've come to the end of today's class. I'm sure the video was helpful. Kindly like the video, share it on the social media, let your friends know about this channel, because on this channel we share useful mathematics tips and also help us conquer examination phobia and treat exam past questions cutting across all kinds of math exam. Bye for now.